This video is about higher order differentiation. If you'll notice, if you, for example, have the function x squared plus 4x plus 5 and differentiate this function with respect to x and get y prime as 2x plus 4, we obtain this derivative that we obtain is another function. Therefore, we can differentiate that function again with respect to the same variable. Now, we call this the first derivative of the function. Okay, if we differentiate the first derivative of the function again, we will be getting the second derivative of the function. Differentiating y prime again, we'll have the second derivative with the notation y double prime, which means the second derivative of y with respect to x. And we just have differentiate 2x plus 4 with respect to x again. The derivative of 2x plus 4 is just 2. And we call this the second derivative of the function. Okay, the second derivative is yet another function. Okay, in this case, this is just a constant function. Y double prime is equal to 2. So if we differentiate that again, we'll get y triple prime, or the third derivative of the function, which is just the derivative of 2, 0. Okay, now we call this the third derivative of the function. And then we can go on and have the nth derivative of the function for any positive integer n. So we can have the fourth derivative of the function, but we'll not be using the same notation anymore for fourth derivative. This is for the fourth derivative of the function. The derivative of 0, which is a constant, is still 0. We continue. The fifth derivative of the function is still 0. And of course, until the 99th, 100th, and for any positive integer n. The nth derivative of this particular function, which is actually a polynomial function, is 0. So this is, in general, nth derivative of the function. We can actually do this for any type of function. So differentiate the derivative of the function. We'll get a higher order derivative. Now for other notations, if we are using f prime for first derivative, so f prime of x. For the second derivative, if it's f double prime of x. For the third derivative, it's f triple prime of x. Now for the fourth derivative, we use number 4 again. So fourth derivative of f of x, fifth derivative of f of x, and so on until we reach the nth derivative of f of x. Okay, of course we can use any other letter aside from f here and for any independent variable. If we are using dy over dx, for the second derivative, it's like this. d squared y over dx squared. It's just read as the second derivative of y with respect to x. This is the third derivative of y with respect to x. The fourth derivative of y with respect to x. The fifth derivative of y with respect to x. Okay, and so on and so forth until the nth derivative of y with respect to x. That goes for any positive integer n. Okay, now let's have some examples. So in example number 1, you're given f of x as the power of x cubed minus 2x raised to 2. Okay, so we have to find the third derivative of f of x, or that is f triple prime of x. Okay, so f of x is a power of x cubed minus 2x. So to differentiate that, we have two options. We can use the generalized power rule, or we may expand x cubed minus 2x squared first before we differentiate. Okay, let's just make use of the generalized power rule. I hope you still remember. So f prime of x is equal to, using the general power rule, bring down the exponent, copy the base, subtract 1 from the exponent. Well, 2 minus 1 is just 1, and multiplied by the derivative of the base, where the base is x cubed minus 2x. Do not forget this part of the formula when differentiating. So we'll have 2 times, it's just x cubed minus 2x. Now what is the derivative of x cubed minus 2x with respect to x? It's 3x squared minus 2. Okay, this is f prime of x. Now again, you have 2 options here. You may simplify this expression by removing the grouping symbols first, or you may use the product rule to differentiate f prime of x to get f double prime. So using product rule, so that you may practice, this is u and this is v. Don't mind this anymore because this is just a constant. We just have to copy that, set that aside, and then multiply the product of get the derivative of the product of u and v. Okay, so if that is u, what is du then? Du is equal to the derivative of x cubed minus 2x, so it's 3x squared minus 2. And then from here, dv is equal to the derivative of 3x squared is 6x. So minus the derivative of a constant, which is just 0. Okay, we shall continue with f double prime. F double prime of x is equal to 2. Just set aside the constant, I said. And take the derivative of u times v using the product rule. So it's u, where u is x cubed minus 2x, times dv, where dv is 6x, plus v, where v is 3x squared minus 2, times du, it's 3x squared minus 2. Okay, now we're going to simplify f double prime of x. Now we have to remove the grouping symbols. Distribute 6x inside x cubed minus 2x, and we'll get 6x to the 4th minus 12x squared. Plus, using FOIL method here, multiplying 3x squared and 3x squared, we get 9x to the 4th. This 3x squared and negative 2 will give us negative 6x squared. This 2 will give us 6 minus 6x squared, and then finally the last terms will give us plus 4. Okay, now we combine like terms inside like terms. So this and this can be combined, and that will give us 15x to the 4th. Okay, this 2 is negative 12x squared minus 12x squared is negative 24x squared, and then the constant. So we can just remove the grouping symbols to finalize f double prime of x, distribute 2 inside the parentheses, and that will give us 30x to the 4th minus 48x squared plus 8. Now to get f triple prime of x, we simply just have to differentiate f double prime of x. Okay, for each of the terms, the derivative of 30x to the 4th is, so 4 multiplied by 30 is 120 x raised to 3 minus 2 times 48 is 96x plus the derivative of 8. So this is simplified, and this is the third derivative of f of x. Now in number 2, we have y equals 1 over square root of x. We have to find the fourth derivative of y with respect to f of, x, of course. Okay, we have to write our function using rational exponents. Every time that you use your radical in the given, you do this. So 1 over x raised to 1/2. Or to make it easier for us to differentiate, instead of using quotient rule, we can just write this function as x raised to negative 1/2. Okay, now we're ready for the first derivative of the function using power rule. Y prime, or the derivative of y with respect to x using power rule, is negative 1/2. X raised to negative 1/2 minus 1. Okay, if we use the general power rule, the derivative of the base x with respect to x is just 1. So it doesn't matter. So it's negative 1/2. X raised to negative 1/2 minus 1 is negative 3/2. Okay, before simplifying, we can continue with the differentiation. Okay, the second derivative of the function, y double prime, again, we are differentiating this now. Derivative of that expression, the encircled part, with respect to x, using power rule again. So set aside the constant negative 1/2. Using the power rule, we bring down the exponent, copy the base, subtract 1 from the exponent. So y double prime is equal to -1/2 times -3/2, and that's going to give us a positive 3/4. By multiplying the numerators and the denominators, we'll get that. And then multiplied by x raised to -3/2 minus 1 is going to give us -5/2. So this is y double prime. Now if we differentiate that, we'll get y triple prime. Y triple prime is equal to, using power rule again, copy the constant, bring down the exponent, -5/2, copy the base, subtract 1 from the exponent. And so when we simplify, we get negative, multiplying 3/4 and -5/2, we'll have a -15/8. X raised to -5/2 minus 1 is -7/2. Okay, now we'll get the fourth derivative of the function. The fourth derivative of the function, using power rule again, is -15/8. Just copy the constant, and then use the power rule again to get the derivative of x raised to -7/2. That's -7/2 times x raised to -7/2 minus 1. And simplifying, we'll get the fourth derivative of y with respect to x equals 15 times 7 is 105 over 8 times 2 is 16. X raised to -9/2. Okay, now we just have to simplify the exponent, the answer. The exponent is negative, so we have to write x raised to -9/2 in the denominator. So it's 105 over 16x raised to +9/2. Now, in radical form, because the given is in the form of a radical, the fourth derivative of y with respect to x is equal to 105 over 16 x to the fourth square root of x. This is the fourth derivative of the function. The function in our third example is a quotient of x and x plus 1. So we need to find the second derivative of f of x. So to differentiate f of x, we need to use the quotient rule. In the quotient rule, we have to let u be equal to the numerator and let v be equal to the denominator. Okay, if u is equal to x, then du is equal to the derivative of x with respect to x is 1. And if v is equal to x plus 1, then dv, or the derivative of v with respect to x, is also 1. Alright, so f prime of x, that is the first derivative of f of x, using quotient rule, is x plus 1, so that is v times du minus u times dv all over v squared. Simplifying, we have x plus 1 minus x over x plus 1 squared. Simplifying further, we have x minus x in the numerator, so we'll be left with 1 over x plus 1, quantity squared. This is f prime of x. Okay, to differentiate f prime, so that we'll get f double prime of x, we can just simply write f prime of x as x plus 1 raised to -2. Okay, so that we'll not use the quotient rule anymore to differentiate f prime. To differentiate f prime and get f double prime, we'll just need the generalized power rule. So f double prime of x, using the generalized power rule, so it's just like the power rule multiplied by the derivative of the base. So what we do is bring down the exponent, copy the base, subtract 1 from the exponent, and take the derivative of the base. So it's a -2 times x plus 1 raised to -3. The derivative of x plus 1 with respect to x is just 1. Okay, so we simplify this to get f double prime and get -2 in the numerator, and in the denominator it's x plus 1 cubed. Okay, this is f double prime of x, or the second derivative of f of x. And so that's the concept of higher order differentiation. You just have to differentiate the derivative to get a higher order derivative of the function. We'll still be using this concept in the next set of differentiation formulas that I'll be giving you.